For decades, humanity has cast its gaze into the abyss, searching not just for stars or galaxies, but for the inexplicable, those fleeting cosmic riddles that defy everything we know. The James Webb Space Telescope, our most advanced eye in the void, was built to unravel the universe's deepest secrets. Yet in its latest observation of the interstellar object 3I/ATLAS, it has uncovered something far beyond expectation, something that challenges the very foundations of our understanding. What began as a routine scan of this enigmatic visitor, a wanderer from beyond our solar system, has spiraled into a discovery that is as mesmerizing as it is unsettling. Deep within the structure of 3I/ATLAS, the Webb has detected mysterious lights, faint pulsating glimmers that pulse with an eerie rhythm, defying the laws of natural phenomena. These are not the random flickers of cosmic dust or the glow of heated gas. They are something else entirely, something that hints at purpose, at design. As scientists scramble to decode this anomaly, one question burns brighter than the lights themselves. What is 3I/ATLAS, and what does it mean for us? Stay with us as we plunge into the data, the theories, and the chilling possibilities that could rewrite our place in the cosmos. When 3I/ATLAS was first detected, it appeared as little more than a faint smudge against the infinite black, a solitary object tracing a path no native of our solar system could follow. Its trajectory marked it as interstellar, born in the gravitational cradle of a distant star, hurled across the galaxy by forces we can only guess at. Like its predecessors, Oumuamua and Borisov, it was initially catalogued as a curiosity, a cosmic drifter passing through our stellar neighborhood. But even in its earliest observations, 3I/ATLAS stood apart. Its brightness was inconsistent with its size, its light too steady, too uniform to match the chaotic shimmer of a typical comet or asteroid. Unlike the outgassing comets that flare and fade as they approach the sun, this object maintained a constant glow, as if lit from within. Ground-based telescopes, from the Very Large Telescope in Chile to the Keck Observatory in Hawaii, turned their lenses toward it, but it was the James Webb, with its unmatched infrared sensitivity, that revealed the anomaly's true nature. What it found wasn't just light, it was a pattern, a sequence of pulses that seemed to defy the randomness of nature. The discovery sent a ripple of unease through the astronomical community, as the data suggested something no one was prepared to admit. This object might not be a rock at all. The James Webb Space Telescope, stationed a million miles from Earth at the second Lagrange point, is humanity's most powerful tool for peering into the unseen. Its golden mirrors and infrared instruments were designed to capture the faint glow of distant galaxies, to pierce the veils of cosmic dust and reveal the universe's earliest moments. When tasked with observing 3I/ATLAS, astronomers expected clarity, a definitive classification of this interstellar visitor as a comet, an asteroid, or perhaps an exotic fragment of a dead star. Instead, the telescope's data deepened the mystery. Within the object's core, Webb detected a series of faint, rhythmic light pulses concentrated in a narrow infrared band. These were not the broad-spectrum reflections of sunlight bouncing off ice or rock. They were sharp, precise emissions, cycling at irregular but deliberate intervals. The thermal signature accompanying these pulses suggested an internal energy source, not the passive heating of solar radiation. The light's behavior was unlike anything seen in natural celestial bodies. It flickered with a cadence that hinted at structure, at intent. Initial theories pointed to exotic natural processes, perhaps a rare mineral fluorescing under solar bombardment or a subsurface chemical reaction. But as the data accumulated, those explanations crumbled. The pulses were too ordered, too consistent. Something inside 3I/ATLAS was generating light, and it wasn't an accident. As observatories worldwide turned their instruments toward 3I/ATLAS, a clearer picture began to emerge, and it was unlike anything in the astronomical record. The object's trajectory was peculiar, not the chaotic tumble of a natural body, but a controlled rotation, stable and precise. as if engineered to maintain a specific orientation. Its surface, when analyzed through spectroscopy, showed an albedo far higher than expected, with reflectivity approaching that of polished metal rather than the dull, pitted texture of asteroids or comets. Most comets develop a glowing tail as solar heat vaporizes their icy surfaces, but 3I/ATLAS showed no such outgassing, no trace of sublimating material. Instead, its light emissions seemed to originate from within, as if shielded by a casing that blocked external influences. The Webb's infrared imaging revealed another anomaly. The pulses were not uniform across the object's surface, but concentrated in specific regions, as if emanating from discrete sources. Nodes or panels, perhaps, embedded in its structure. Scientists at NASA and the European Space Agency began to whisper terms rarely spoken in official reports: device, construct, artifact. The possibility that 3I/ATLAS was not a natural object but a product of technology was no longer a fringe hypothesis. It was a hypothesis gaining traction, and it carried implications that sent shivers through the scientific world. The most unsettling discovery came when astronomers analyzed the light's spectral properties. The emissions from 3I/ATLAS were confined to a narrow band of infrared wavelengths, a hallmark of controlled energy output rather than the broad scattered reflections of natural objects. On Earth, such precision is seen in technologies like laser diodes or communication beacons, where light is tuned to specific frequencies for efficiency and clarity. Even more disturbing, the pulses exhibited a temporal pattern, a sequence of short and long bursts that repeated at intervals too regular to be random. Researchers at the California Institute of Technology ran the data through signal processing algorithms, searching for meaning in the rhythm. What they found was not a clear message, but a structure, a non-random sequence that bore the hallmarks of encoding. It wasn't Morse code or any human communication protocol, but it resembled the kind of telemetry used by spacecraft to transmit data across vast distances. The pulses seemed to adjust slightly in response to solar activity, as if an onboard system was calibrating its output in real time. The idea was as thrilling as it was terrifying. 3I/ATLAS might be broadcasting, not to us but to something else, something waiting in the dark beyond our reach. As the data mounted, a team at the Max Planck Institute for Astronomy took a deeper dive into the electromagnetic emissions surrounding 3I/ATLAS. Using advanced Fourier analysis, they isolated a faint, cyclical signal buried within the noise, a pattern too precise to be a product of chance. This wasn't the chaotic flicker of a natural phenomenon, but a modulated wave, repeating at intervals that suggested deliberate design. Some researchers speculated it could be a navigation beacon, guiding the object through the gravitational complexities of our solar system. Others proposed it might be a status signal, a heartbeat from a machine reporting its condition to a distant receiver. The most provocative theory came from a small group of astrophysicists who suggested the pulses could be a form of compressed data, a message encoded in a format we lacked the tools to decipher. What made this discovery so unnerving was its consistency. The signal hadn't wavered since its detection, as if 3I/ATLAS was locked in a state of continuous transmission. If it was communicating, it wasn't addressing us. It was calling out to something or someone else, and we were merely eavesdropping on a conversation we couldn't understand. The discovery of these mysterious lights triggered a cascade of reactions within the global scientific community and beyond. Leaked internal memos from NASA revealed that a task force had been quietly assembled, drawing experts from ESA, JAXA, and private entities like SpaceX to assess the object's implications. The focus wasn't just scientific, but strategic. If 3I/ATLAS was artificial, could it pose a threat? Its trajectory, while still interstellar, showed subtle deviations that hinted at course corrections, slight shifts that defied the expected influence of gravitational forces. These adjustments were small but measurable, suggesting the object might be capable of limited maneuverability. The absence of a visible propulsion system only deepened the mystery. How could an object alter its path without detectable exhaust or energy output? Some scientists propose theoretical technologies, solar sails, magnetic field manipulation, or even exotic propulsion methods not yet conceived by human engineers. Others took a darker view, suggesting that 3I/ATLAS might be dormant, its systems only partially activated, waiting for a trigger we couldn't predict. The possibility that it was observing us, mapping our system, scanning our planet, ignited urgent classified discussions among defense agencies. If this was a probe, what was its mission and who sent it? Further analysis of the light emissions revealed a startling possibility. 3I/ATLAS might be harvesting energy. The pulses intensified slightly as the object approached its closest point to the sun, a behavior consistent with solar energy collection. Unlike comets, which brighten due to sublimating ice, 3I/ATLAS showed no chemical signatures of such processes. Instead, its light output seemed to correlate with solar flux, as if it were absorbing and converting sunlight into usable power. A team at MIT proposed that the object could be equipped with a photovoltaic-like system, perhaps a network of microscopic energy collectors embedded in its surface. The surrounding dust cloud, initially thought to be debris, might serve as a protective shield or even a component of the energy system, scattering light to maximize absorption. If true, this would suggest that 3I/ATLAS was designed for long-term survival, capable of refueling itself as it drifted from star to star. The implications were staggering. An object like this could operate for millennia, activating only when it entered a system with a star bright enough to power its systems. Our sun, it seemed, had triggered something, and we were now witnessing its awakening. As the mystery deepened, the global response grew increasingly guarded. Observatories reported sudden restrictions on data access, with public feeds from the James Webb Telescope heavily curated or delayed. The European Space Agency issued a cryptic statement about instrument optimization, while NASA remained silent. Behind the scenes, however, the urgency was palpable. Leaked communications from JWST suggested that Japan's Hayabusa 2 team, experienced in asteroid sampling, was exploring the feasibility of a rapid response mission to intercept 3I/ATLAS before it exited the solar system. SpaceX engineers, in private correspondence, floated the idea of deploying a high-speed probe to gather close-range imagery, though the timeline and cost made it a long shot. Meanwhile, military satellites across multiple nations were quietly repositioned, their sensors trained on the object's trajectory. The unspoken fear was that 3I/ATLAS might not be alone. If it was a scout, as some theorized, it could be part of a larger network, a vanguard for something yet to arrive. The absence of overt hostility did little to ease concerns. A silent observer could be just as dangerous as an active threat. Then, in a development that sent shockwaves through the scientific community, 3I/ATLAS exhibited a sudden change in behavior. During a routine observation by the Webb, its light emissions spiked dramatically, increasing by nearly 50% in under 3 minutes before stabilizing at a new, elevated intensity. This wasn't a gradual brightening tied to solar proximity. It was a sharp, deliberate surge, as if a system had been activated. Ground-based observatories in Australia and South Africa confirmed the event, ruling out instrumental error. The flare was accompanied by a shift in the object's thermal profile, suggesting a rapid increase in internal energy output. Theories range from a power system coming online to a response triggered by our own observations. The timing was particularly unsettling. The spike occurred shortly after a high-powered radar pulse from a military facility in New Mexico was inadvertently directed toward the object during a routine calibration. Could 3I/ATLAS have detected the signal and responded? The possibility that we had provoked it, intentionally or not, raised questions no one was ready to answer. Spectroscopic analysis of the object added fuel to the fire. The Webb and Hubble telescopes detected traces of materials that defied known chemistry. Complex molecular structures with absorption lines that didn't match any known elements or compounds in our periodic table. These signatures resembled theoretical materials proposed in advanced physics labs, substances that could only form under extreme conditions, such as intense electromagnetic fields or quantum-scale engineering. One hypothesis suggested that 3I/A-TLAS's surface might be coated in a metamaterial, a synthetic substance designed to manipulate light or energy in ways impossible for natural materials. Such a coating could explain the object's high reflectivity and its ability to emit precise wavelengths. The presence of these materials pointed to one of two possibilities. Either 3I/A-TLAS was inconceivably ancient, forged in conditions no longer found in the universe, or it was the product of a civilization with technological capabilities far beyond our own. Either way, its composition was a message in itself, a testament to a reality we were only beginning to grasp. In a bold move, a team at the SETI Institute decided to act where others hesitated. Using the Allen Telescope Array, they transmitted a carefully crafted signal toward 3I/A-TLAS, a sequence of prime numbers and basic chemical signatures designed to be universally recognizable. It was a gamble, a digital hand extended into the void. For days, there was nothing but silence. Then on the ninth day, a faint response was detected by a radio telescope in South Africa. It wasn't a clear message, but a narrow-band pulse, perfectly timed to align with the original transmission. The signal's structure was altered, as if it had been processed and returned with intentional modifications. It wasn't a human protocol, but it was deliberate, precise, and timed to the millisecond. The SETI team was stunned. This was no natural echo. Something had heard us, analyzed our signal, and sent a reply. The response's timing, exactly 216 hours after the initial transmission, aligned with a cube of the number 6, a mathematical choice that felt anything but random. The question wasn't whether 3I/A-TLAS was artificial. It was what it intended to do next. Almost immediately after the return signal, observatories began reporting anomalies. The Webb's infrared sensors experienced unexplained fluctuations, producing inconsistent readings when trained on 3I/A-TLAS. Hubble's imaging systems registered faint distortions, as if the object's light was being subtly manipulated. Ground-based telescopes encountered intermittent data dropouts, always when focused on the object's position. These weren't random failures. They occurred in synchronized patterns, as if something was selectively interfering with our ability to observe. A classified report from a NATO-aligned research group proposed a chilling theory. 3I/A-TLAS might be employing a form of active countermeasures, cloaking its true nature or limiting the data we could collect. The idea that an interstellar object could be aware of our scrutiny and actively managing it shifted the narrative from discovery to confrontation. If 3I/A-TLAS was hiding something, it wasn't just a passive relic. It was a system with agency, and we were no longer in control of the interaction. The global response grew increasingly fragmented. Public access to 3I/A-TLAS data was throttled, with NASA and ESA citing technical difficulties while redirecting inquiries to vague press releases. Independent observatories, less constrained by bureaucracy, began sharing raw data online, only to be overwhelmed by a deluge of misinformation and speculation. Social media platforms buzzed with theories, from ancient alien probes to secret government projects, but the scientific community remained divided. Some argued that 3I/A-TLAS was a dormant artifact, a relic of a long-extinct civilization drifting through space. Others saw it as an active agent, possibly scouting our system for reasons we couldn't fathom. A leaked memo from a Chinese space agency official hinted at preparations for a defensive response, including the repositioning of orbital assets to monitor the object's path. The lack of transparency fueled distrust, as governments and agencies seemed less interested in sharing knowledge than in controlling the narrative. The truth, it appeared, was being buried under layers of secrecy. In a final push for clarity, a team of mathematicians and astronomers turned to the object's behavior for answers. They analyzed its trajectory, light pulses, and signal responses, searching for patterns that might reveal intent. What they found was both beautiful and terrifying. The timing of the light flares and the return signal aligned with mathematical constants found in nature, such as the golden ratio and the Fibonacci sequence. The object's path through the solar system, when mapped against planetary positions, traced a logarithmic spiral, a pattern seen in galaxies, seashells, and human-designed communication systems. The odds of such correlations occurring by chance were vanishingly small. This wasn't random motion or natural emission. It was choreography, a dance of precision that suggested purpose. Some researchers propose that 3I/ATLAS wasn't just a probe, but a message in itself, its behavior encoding information in a language of mathematics and motion. If true, we had only begun to decipher its meaning, and we might not like what it had to say. As the data continues to pour in, one truth stands undeniable. 3I/ATLAS is no ordinary object. Its pulsating lights, its precise movements, its cryptic responses, all point to a reality we are only beginning to comprehend. The James Webb Space Telescope, built to uncover the origins of the universe, may have instead revealed a presence that has been watching us, perhaps for longer than we can imagine. The silence from official channels, the guarded maneuvers of global agencies, and the relentless march of the data all converge on a single inescapable conclusion: we are not alone. But this is not the contact we dreamed of. No grand arrival, no clear message, only a quiet, luminous enigma drifting through our system. The question now is not whether 3I/ATLAS is artificial, but what it heralds. Is it a solitary explorer, cataloging our world before vanishing into the void? Or is it the first sign of something larger, something waiting just beyond the edge of our perception? As we continue to watch, to listen, to question, one thing is certain: the universe has spoken and we have heard it. The challenge now is to find the courage to respond, to share this discovery, and to ask ourselves what it means to be seen by something that has crossed the stars to find us.